Alright, hello everyone. Um, Today I'm gonna show you my progress on the Yodex Rover delivery. So this is version 3. Let's call it version 3. So the first version you saw is my first commercial. The second version you saw is in the previous video. And for the third one, so I talked about potential improvements I could make for the future, and I've made some of them. Some of them I failed to implement, such as switching the neural network to recursive neural network structure that has some sort of memory. So this one is reaction-based neural network. Please don't quote me on that. I'm not exactly sure. But so this one includes some of the important improvements. The main improvements being are lidar improvements. So as you can see, this is a point cloud array that's considering lots of angles, even elevation. You can see the green stuff shows the potential ground, so it checks like the distance difference between points. Here you can see, right? So it becomes red. So when it thinks it's like more of a wall, it'll become more of a red color. I'm sorry. So yellow is like moderate, potential. So I've also improved some other systems, so the overall experience with the delivery is going to become much better. So in this video, I'm going to talk about the improvements, potential ones, and the current one. I'm going to show you off some features, not like features, more of a like how it works. And so let's start. Let's start with showing you how it currently handles such environment. So I'm not gonna say it's perfect right now. It's obviously not perfect. As you can see, like sometimes it's pretty jerky. Yeah, don't bother with the screen above. It doesn't update very quickly, so that's why there's a lot of noisy image, let's call it so. But even since the version 2, this has improved a lot in terms of just navigating. Like here's the, I don't know, some kind of mistake. Yes, it also knows how to reverse, but it's quite afraid of the wall there, so a little more training is required there, I assume. Let's see if it can figure it out. If it doesn't, I'm just gonna help it a little. Yes. So your delivery is ready. 1 meter away from you. Good. Same functionality. I also added this wobbly thing. Thought it looked cool. Yeah, visuals are always a matter of, yeah, as you can see here, matter of improvement, but I'm not the best builder in the world. I like to make software, not hardware, but either way. So as you saw here, it worked pretty good. Now let's do exactly the same scenario, but first, while I'll be going, I'll place extra items, so it has to navigate around it. Right. Alright, let's try. Let's make a couple more adjustments here. I'm gonna block some things off here. Oh, I don't know how can... Okay. Turn around, boy. Alright. Doesn't have any memory, so I wouldn't expect it to work that well. Okay. Did navigate successfully here. Let's see if it can navigate here. So it has to go to this point. Certainly is afraid of things for no reason. I'm gonna say it certainly needs a little bit more data. Let's see if it can figure out which way to go. So initially it thinks it has to go this way. This is the input. I mean, it's quite clear where you need to go. So it decided to reverse all the way. Maybe it thinks it doesn't see it. Oh, there we go. Almost did it. Oh, look at it. It figured it out. And of course you're not gonna go, oh, okay. Now, this time it went in. That's good. Also, the LiDAR improvements, let's talk about it. So, here's the scenario I have never tested before, but on this example, I'm gonna show you why the new LiDAR change is important. So let me change something very, very quick. Alright, so this is what LiDAR currently sees, right? So you got the screen, and you got the holograms. This is what it sees right now. As you see, there is certain levels. So here's the bot itself, and here's what it sees. So it's much more accurate. The size of the block approximately shows the size of the endpoint. So like, let's test it out here. So it will see this. But if I do it like this, yeah, I think it's actually correct, not approximate. So like, you will definitely see an issue that I've talked about earlier, about it not seeing small objects until it's close enough. Right, that's too high, I think. Yeah. Like, you can see it sees it, but there's a limit. Like, here we go. So I thought about that, like, do I really need to see small objects that far away? I thought maybe it's important to have more resolution when you're up close to the object, so you exactly know how it looks like and how to go around it properly. Because when it's small distances, right, there's like a little tunnel or something. Like, any change of the object, or like of the size from another perspective, may throw the whole system off, and you have to know it in advance. And so, for extra accuracy and just overall better resolution, I decided to go down with this way. So, as you can see, it also, so besides pointing up, it also points down, as you can see, right? So it points up and points down. This was important. So when it gets up close to, let's say, a curb, let's make this a curb. Maybe this size, a default Gmod curb. So it used to block off all the sensors. So it literally thought that this is a wall. Like, you cannot go up the curb. Although it can. Maybe a little lower, yeah. And with this change of it seeing further up and further down, you can actually identify whether it's a curb or not a curb, or it's a wall, or I don't know. Let's find that object, or this thing. Like, how can you say with one set of traces that you can theoretically go through here? Like, how can you do that? If there's something similar. Like, what if there is a ceiling level, right? Like, right now, it will chop the whole LiDAR sensor off, which is fake. But either way, it has to be done, because you can go in many different places when not having that exact logic, and you have to account for every case, potential case, with generalizing. So let's try this out. So let's say it has to go here, right? So it passed this point, but now I have never tested this scenario, but let's see if I can figure it out. There's not much of a data for elevation training, but in theory, so it sees the point is there. It knows there you shouldn't reverse, because it will increase the distance, right? They're always trying to put the bearing of the whole thing to the point, but it has to avoid objects, and in this case it has to avoid falling down. So let's see what it does. Let's also do, it was my Discord notification, guys. Right, so it thinks it wants to go in reverse in this case. Interesting. Let's see if this wall throws it off. Let's put it way further away. so it's about to fall, which shouldn't be happening. But either way, let's help it out a little. Oh, look here, it actually did try, because I had a little data probably somewhere with elevation changes, and it did learn it, it did generalize it, but not very good, as you can see here. Or maybe it was something else, maybe it was just a random thing. Oh yeah, that wobbliness is definitely not helping it. So let's let's let it reach the point. You're gonna reverse. Oh, here's an example of poor training again. Well, actually no, it did went over that, which is good. Alright, let me show you another example. In the last video, there was a moment where the drone just... Oh, the drone? No, not the drone. The rover just refused to go forward, and it was an issue with AEB, which is autonomous emergency braking. It's probably not the best naming for this exact case for this rover, but it's pretty much does the same thing. It basically shoots 3 traces forward, so 1 in front, which roughly matches the size of the whole rover, and 2 on the sides, which are pretty large, and it's helping for potential collisions coming from the side, so you have to calculate it, because imagine the rover drives and it will only stop when you're only in front of it, but like the motion of the player literally tells the system that you're about to cross in front of it, and it has to brake, otherwise it's gonna collide with you. And so it doesn't do the braking on its own. It's just outputting the distance and the target to the other systems, where it figures out the whole braking system, like the whole braking idea of the rover, whether it's close to the wall or it's close to the person or anything else. So here I wanted to show you that let's do it like right here. If I was to cross, it would brake for me. Here, let's show it again. So here it drives, and here I'm running in front of it, and it stops. You could see similar behavior with the concept. Here I'm just intimidating it. Can't go, you can't go. Let's see if I can make this one. Probably for speed control and braking, I should probably make another algorithm, or maybe even make a small neural network. So like there's not exactly a point of braking here. Like you can see clearly, like all the way there. Like you know how the whole thing looks like. There's no problems here. Just identifying it. Just go forward, full speed, and then brake at the end. But either way, the whole point of the rover has been pretty much solved. It's just a matter of further neural network improvement, such as potentially changing the structure, as in from feed-forward neural network to recursive neural network with memory, and or increasing the size of the database and adding more edge cases, just overall better quality for the database, which obviously needs improvements, as you saw with this example, or just it being wobbly going forward sometimes. So yeah, and that's guys it. Thanks for watching me. Don't forget to subscribe and wait for future updates.